Okay, so thank you for joining in. I thought that I had said to you last week that we would use the same meeting link and start at 4. But when I came in at 4, I didn't see anybody in the room. And then I realized that maybe you didn't remember that. So hence I had to
was there,
send out
miss.
the link again. You were here at 4?
Yes, ma'am.
Oh, okay, I didn't see anybody. In any case, my computer decided that it had to restart. Um, yeah. So we're here now. Let me ask before we begin though, how has it been going in terms of your other modules and in terms of your assignment? Let's start out with the other modules first.
All right, miss. We finished networks. We just have the lab for network to submit Friday. We did a test last night. We're in a test, you asked me, miss. But
Pardon? World winner for test?
yes, miss. Format was all over the place, but the format that they was set because it had to be randomized.
Okay.
Yeah, we were all over.
Okay.
The only other course, my 2 courses are finished for me now.
Which is the other course?
Signals and systems.
Okay, that is with Mr. Fraser.
Great. Yes, ma'am.
Okay, you do that online?
No, ma'am.
Okay. All right.
Miss, what about the math? Why we have internet stuff on
What
math?
about the what?
Math.
All right.
Math too. We haven't
Okay.
have any lecture since,
No, I was really talking.
here?
I was really talking about in school
Engineering.
in engineering modules. Outside of engineering, there is very little I can do other than to note it. You will be an announcement will be made by the university soon. Should be, if not this evening, by about tomorrow regarding how we will proceed from here on in. But for me, this is my last session with you. I will post the video so that those who have not seen it can access it when they can. Have you been able to utilize the data plans that Digicel is giving to students?
No, that don't work for me.
But with your university, don't you have a UTech email address?
Miss?
Don't you have a
I don't
UTech
know.
email address? Have you checked your portal to see what it is?
No, miss.
All right. Check. But what you've tried to access the Digicel offer?
No, miss. I'm at home and my Wi-Fi is okay and my post speed is okay.
Okay.
No,
so you're one of the fortunate.
What is the fortunate, miss? What would make me more fortunate is some news on the lab for business. When did you get anything on the submission of it?
Submission of the lab?
Yes,
didn't you do a lab test the other day?
Yes, ma'am. But we still have a lab report on the Friday.
Okay. Well, don't worry about that. Just do your work as you can. Just do your work.
Is that lab a group lab?
Yes, that's same lab at Kahoon.
The group lab?
Yes, Kahoon, that's same lab I'm talking about.
Group of too much? 2?
Yes, someone I first hear about the lab.
Yeah, because somebody that thinks that individual lab. I want to verify.
No, it's group of 2. That's what Mr. Wright said.
Anyway, Let us
No, man,
see
I
what
talk
we
about,
can do.
network club. Network club, me I talk about. The AC resonance lab.
And the
Gentlemen,
next class we number
gentlemen, come on.
Oh, but Mr.
Stick
Right,
to
change
the
the date.
topic, gentlemen, stick to the topic. Programming for engineering.
Mr. Edmond, there, a 15 in change the date. So.
All right. All right. In terms of the assignment that you have for me, how is that going?
coming on with.
Okay.
We'll
Do you know of anyone who is struggling with that assignment or, but it should be okay because you don't really have to be together to do it.
There was a person who expressed some problems last week, but I don't know if he got that sorted out.
Okay,
He
well,
was supposed to send.
I haven't received anything. Maybe I've been getting a ton load of emails, so maybe spam emails, so hopefully it is not caught up in all of that. Let's see, is there anything else that I need to address before I start? No. So we're going to begin. We're looking at file streams this week. You would have seen on the screen already. I haven't shared this file with you yet. I will share it when we end the session. Or let me share it. No, let me share it when we end. It's going to be a little bit much for me to share it right now. File streams, each year I deliberately leave this as the last topic. But the good thing, I don't know if it's a good thing or it's a bad thing, that you can't access university labs while you're doing this. You have to do this on your own laptop. Because what we have been doing so far in all our programs, in our writing programs, is to actually use an input from the keyboard. Oh, this is wrong. An input from the keyboard and an output to the screen. But what if you're writing a program where the user is not necessarily needed to enter information, and the information that is required for the program to run is actually stored in a file? Because when you're in an industrial setting or a commercial setting, data is found on files. It's not somebody who sit there and enter data based on when the computer or when the program needs it. This information is stored in files. So you should be able to access information in files. You should be able to process the information and send the results out to other files for other programs or other people to utilize. All right. So this is what we're going to be looking at, file streams. When we talk about file streams, we're talking about streaming information to and from files. That's all it means. Let me open up a blank screen. All right. So we have a blank screen there now. So what we're used to, all right, so what we have been used to is using that. I hope that looks like a floppy. Does it look like a floppy?
Yeah, John was a floppy disk.
Yeah.
A few people don't know that means.
Oh, I know what I'm going to draw then. Since nobody knows what a floppy is, I'm the only old one in here.
Flash drive.
That looks better. You know what that is? All right, your jump drive. Now, even though I don't recommend it, what most of you have been doing is saving your programs on a jump drive for you to transport and use wherever you want. And you save data. When you run your program and you collect data, you've been saving data on your jump drive. So what has been happening is that you have been you have been running your program. Let's call this your program over here. And the secondary storage. All right, it's not the RAM, it's secondary, it's external. Whenever you save your data, you're saving it on your jump drive. And what you have been doing is when you're running your programs, you then take information from your secondary storage and you send it to your program over there. And then what your program does is to process that information and then take it, send the process information for storage from the program back to your jump drive. Yeah? This doesn't involve a keyboard input or output. It is directly from a file on your jump drive to a program and then from your program back to the jump drive. Okay. What we've been doing before is using the keyboard and the screen. Now, how do we actually include that in our programs? How do we actually write programs to allow us to do this? It's not hard at all. We do that with using objects that are called streaming objects. They're streams, all right? And whenever we're talking about streams, we're talking from the perspective of the program. Okay, we're looking at it from the program. So you have information coming into the program from the jump drive or from your secondary storage. Can you mute, please, Mr. Calhoun? And
all right, I hit that now.
Come on.
Hey, all right.
All right. You also have information that is leaving your program, going out to the jump drive. And these are objects. These are actual literal paths that you're creating. All right. In order to link your secondary storage here to your program, you have to create these links here. One to take information in and one to take information out. It may be that you only need to take information in from the secondary storage to the program, all right? Or it could be that you only need to send information out to it. You can also do both. But these are actual links that you have to establish. Now, you remember in all of what we've been doing, we've been using two terms. You've been using cout, yeah, and cin. Cout and cin are actually objects, and they're objects, and I told you I would come back to it later on down, but they're objects of a class called IOStream. IOStream includes the header file, includes a class. And in that class, in that header file, what happens is that cout and cin are actually objects that are members of the IOStream. That are not members, they're objects of the IOStream class. We don't do any declaration of those two objects. They're already there, declared, and available for us to use. Okay, Now, we're not using cout and cin right now, not in file streams. You can if you want to, but they're just regular input and output. What we will be using are file streams, and you have input file streams, and you also have output file streams. These are both classes, but unlike cout and cin, we have to declare our objects. One for input. Remember the reference, point of reference is a program. So you have one for input and one for output. And you create them when you need them. Okay, let me go back to the other Word document. Tell me if I'm going too fast, if you're struggling here. Okay. Now this says previously we have used functions in the IOStream library to carry out output from the screen using, hold on, I can't see when I have this thing on. Okay. Yes, we've been using cout and cin. There are times when data is to be used. There are times when the data to be used is stored in files and must be accessed from within a program. There are predefined functions in C++ that do this for you. These are found in the fstream.h library, not ifstream. However, you will still need to include the IOStream header, as you may need to use the cout and cin objects. All right. I don't mind if you do that, include IOStream. So for every fstream output that you do, output to the screen as well, you cout as well, so that you can see exactly what is happening in the file. Once you get comfortable in doing the fstream only, you no longer need to use cout. And all right. Before a program can read values from a file, it must construct a connection between the file and the program. And that's what I was showing you with my graphic of the jump drive and the program. Now, this is done by declaring both the input file stream name and the output file stream name. All right. Now,
Yes.
Yes?
So this file that we're talking about, it has to be a C++ file?
No, this is a regular, it can be a Word document, it can be an Excel spreadsheet, it can be a text document, any type of document that you want. It's data.
Okay.
All right?
Okay.
However, for what we will be doing, we'll be doing text documents only. All right? Now, you have here the format of the declaration. Now, the words ifstream and ofstream, these are reserved words in C++. All right? They are the names of the classes that you use to create the objects. And the objects are the input file stream name and the output file stream name. All right, so you can name it whatever you want. If, however, my suggestion to you is to always let your stream name be representative of what it does. So if it is going to take information in to your program from a file, call it get or in or input something. All right, let it be representative. You could call it table if you want. It still works. But once you take your eyes off the program for too long, you might forget that that is what it is supposed to do. So I always suggest you let the name be representative of what it is that the stream is doing. And the same thing with the output. Name it out or extract or send or something like that. Something that is representative of sending information out from your program to a file. All right, so that's the first thing. We're going to look at our program and we're going to modify it. I go through the program, and as I say, the only way to learn how to do this is to practice. But I'll go through the steps of the program. All right. Now, all you have done there when you create the links, these two links that I have ticked, all right? All that you do when you declare the links is to create them. You haven't actually stated which file on the jump drive or the secondary memory storage that it will access. You only create a link. But now you have to state exactly what file should be opened. Because on your jump drive, you can have a multitude of files that can be accessed, even if it is empty. If you are going to output something, you have to state where it should be output to. So now, what you now have to do is to identify exactly what file you're going to open. And to do that, the program has to state the name of the file to open. And you see here in brackets, I have including path. And I will get into that a little bit more because you may need to know how to identify the pathway to the file that you need. All right, but the general syntax for opening the file or linking your program to the file is could be an input stream name or an output stream name dot open. All right, now understand this. Let's back up a little bit. When you're working with objects of a class, every object has access to all the functions within the class. Now, one of the functions within both the OF stream class and the IF stream class is open. All right, that is one of the functions, open. Hence, you have the output file stream name, access operator, which is a dot, open. And then within the brackets of the open function, in the parameter list is a string, which is the name of the file. All right, the name of the file. And that name may also include the address or what we call the path, how to get to it. So the function is actually this, just a simple open function, but it is a member of the class. Here, therefore, you have to use it with the object name dot open. All right. Now, the open function opens files enclosed within the brackets and establishes a connection between the program and the file. Now, once you open it, you have to test to see if the file is actually open. All right? Because what if you try to open a file to read from it? If the file doesn't exist, you can't read from it, can you? Feedback here, ladies and gentlemen. If you open, nobody's responding. Are you all there? Still there? Don't let me start picking on people.
Yes, sir. Here, we're here.
Okay. All right. So when you open a file, you have to test to see whether it is open. And to test to see if it is open, there is another function that does that. And that function is _open. All right. And again, you use the object name. So whatever you call this file stream, it could be out. You have out.isOpen bracket. And what that does is to tell you whether or not, or what will happen is that you will get a response and it is either true or false. And you use that within an if statement. So you'd say if out is open and close bracket, that can either be true or false. And if it is true, you do something. You could do your output. However, if it is false, then you can't do anything. You can't access the file because it doesn't exist. Or you could say if it failed to open, then if it failed to open, then you can't do anything. But if this returns false, then you know it did open, so you can proceed. All right. Personally, I like talking in the positive, so I prefer to use isOpen because speaking in the negative can be a little bit confusing. All right. There's some other functions available like getLine, and it reads the line of text from the file, and it reads it in as text. Yes, Mr. Thompson? Is it Mr. Thompson? What was the question? All right, no question.
Excuse me, Miss.
Yes?
So, yes, ma'am. So would I have to like store value into a variable and then like test? Would I have to store the return value into a variable?
You can if you want to. You don't have to. You all right, understand. Your output file stream you can use just the same way as you use a cout. Once you create the output file stream, you use it exactly like how you would use cout. The only difference is the output file stream will send the information to a file, whereas cout sends it to the screen. All right, that's why you can use both of them together. So you know straight away exactly what is going in the file because you can see it on the screen as well. Okay? All right, let's proceed.
All right.
There's some other functions that are found in the class that the object has access to. You have the end of file function. It returns it returns true if the last operation read the end of file mark. So every file has a mark that you won't see visually, but there is a point to which a file ends. And there is an end, the end of file function will read that. If you're at the end of file, this will return true. If you're not, it will return false. Now, my suggestion to you is that when you are done utilizing a file, you close it. All right? See this close here? Always close your files whenever you're done reading from it or whenever you're done writing to it. And I'll explain why. Let's go back to my little graphic here. Say you open a file on your jump drive to read from it, okay? Your jump drive is separate and apart from your secondary storage is separate and apart from your memory on your computer. Yeah, you can actually remove it, can't you? If you're using your hard drive or your storage, secondary storage on your computer, what will happen is that as long as that link remains, there may be other programs that can access your files via that link. And that's what hackers spend a lot of time doing. They put, when you go and visit all of these sites and play all of these games on Instagram or Facebook or all of these sites, dodgy sites that you visit, they inject small programs on your computer that just wait, sit there and wait until you open a link to a file. And once that link is established, one way or another, it will now go and get the data that is stored. So whenever you have opened a file to read from it or to send information to it, please close the stream as soon as you're done with it. Okay? Just a little tip. You don't have to. It doesn't affect how your program works, but it's always a good idea to close it. All right. Let's take a look at our program. There's some more notes here that I'll get to in a minute. Okay, no, let's go through this a little bit more. But there's a program at the end of this that I am going to copy and paste into code blocks so that you can see how it works. All right. Normally open code blocks before class. I don't know why I didn't do that today. Okay. Settings and editor. Okay, you can see that. All right. Let's call this stream on. All right, so I'm just going to paste this right there. Now, look, let's start at the header files that I've included. All right, this is just a small program that outputs the square of numbers from 1 to 10. All right, it will output them both on the screen and in a file. Now, I want you to take a look at it carefully. Let's start out at the first 3 lines. I'm including some header files. You know, the first one, IOStream, because I want to use the cout. All right? That's the only reason why I'm including it. But I'm including the fstream header file. Now, the fstream header file is actually, again, like IOStream, a class. And within that, it has 2 child classes, one called IOStream and one called IFstream and the other one called OFstream. So IFstream is the input file stream, and the other one is output file stream. All right, includes IF stream and OF stream. Now, it's interesting. You remember last week when we were doing inheritance? Anybody remember that? All right.
Yes, miss.
Okay. So it's interesting that you can declare an object that is an OF stream or an IF stream. However, you can declare one object that is both IF stream and OF stream. And you do that by declaring it as an F stream. But you can try that when you choose. But for now, I prefer if you use OF stream and IF stream. All right, so now let's look at this program. You're used to your int main. I have declared here two variables, two integers, x and y, right, which we'll be using in our program because we need to be able to store data in the program itself. So that storage is actually in the RAM. When you're running your program, all data that you use in your program, they're stored temporarily in your RAM. However, we can send information directly to secondary memory, all right, secondary storage. Now, in line 7, I am declaring an output file stream. So I have OF stream out. Remember that link that I'm talking about that I'm creating out that is sending information out from my program, that purple line there? That is my OF stream that I've created and I've called it out. Okay, that's all I've done there. But in line 8, I am now linking my out, my OF stream out, to a particular file called test stream, all right, .doc. I'm gonna change this from doc because we don't use doc anymore. We use docx. I could use, and docx, it's a Word document, or I could have used .dat or .txt if I wanted. I'm gonna try docx to see if it works. Sometimes it will give me a little problem. If it does, I will change it. Let's change this here. All right. Now, after I link, and what that does is to say that this output file stream here that I have in the purple is linked to a particular file now. And that particular file is called test stream. Okay. Now, my next line is to check to see if it failed. Now, I know I said I prefer writing in the positive. This time, for some reason, I wrote it in the negative. So this is now checking to see if I failed to create that link. All right. But to make it positive, I put the not symbol in front of it. All right. That's the exclamation sign. I hope you did this in the lab. So if out.fail did not happen, meaning that if it did not fail to open, then I can carry out some tasks. And the task that I carry out is to output again to the file. The program outputs the square of numbers 1 to 10. And then I use a for loop to calculate the square of numbers 1 to 10. And I output the squares. Okay? I'm not outputting x, I'm just outputting the squares of the numbers 1 to 10. So you'd expect to see what? 1, 4, 9, 16, 25, and so on. And my next line is to mimic that operation on the screen. You know what the cout is. It just mimics it. It just outputs it on the screen. When I'm done, I close the file, and that's it. However, if I was not able to create that link to a file, what would happen is none of this within these brackets here. None of that would occur. It would go straight to the else, which would be error opening file, program will now close. Tell me something, have you ever seen anything like this pop up in any program that you're writing? Or not writing, any program that you're running? Have you ever seen an error message like that?
I think so, yes.
No.
Yeah.
Okay.
Not for me.
Yeah,
You've never seen that?
Nope.
Okay. There are a number of times I
it gives
try running programs and it tell me that there's an error opening the file. All right. But let us see if this works. Save and compile it, and hopefully it will compile. Oh, it gives me one error. Fstream.h. Let's change that to fstream. Okay. Because it's not a header file, it's actually a class. And Fstream is not declared in this scope. Oh, what am I missing, ladies and gentlemen?
Oh.
I knew that program looked away.
It looks funny. Okay. All right. Compile again. No errors, no warnings. All right. Now, before I do anything, I want to go to the folder that I use for this, P4A. All right. I want you to take a look at all of what I have here in this folder. I don't know if you can see it. That's better. Tell me, do you see any file or anything at all in this particular folder called test stream? Am I going too fast? Better yet, let's do this in alphabetical order. All right, now this is in alphabetical order. So test stream would fall somewhere here. Yeah? Do you see anything called test stream?
No.
Nope. All right. Let's go back and let us run this program now. I hope it works. It works for the output to the screen. We see the squares of 1 to 10, 1, 4, 9, 16. I don't know why it does this. Give me 24 instead of 25, and it throws off everything a little bit. Let me just change something here. I am going to call this. Hold on. I'm going to fix it and put y as a float. Yes, sir? I'm changing y to a float. That should.
I noticed that when I'm using
Yes, I'm listening.
In the project, when I'm using put to the third power, when I'm using power and raising to the third power, it normally gives me a missing value, like plus or minus 1.
I don't know why it does that, but
okay.
I think this should fix it. So let's compile it and run it again, and hopefully it fixes. Yes, it does. All right. So the square of 1 is 1, 2 is 4, 9, 16, 25, 36, 49, 64, 81, 100. Okay, everybody happy with that? All the squares of 1 to 10? Yeah?
Yes, ma'am.
Okay, let's close that. Now let's go back to my file. Do you see anything there called test stream?
Yes, miss.
Look at the time it was created, 5:24. It's now 5:24. Fingers crossed that I can actually open it. If not, I'm gonna change it to yes.
TXT.
Okay, it's not opening it for me, so I'm gonna change it to a TXT. As a matter of fact, let me go back to the folder and delete it. All right. Change this from a docx to a TXT or a DAT if you wanted to, a data file. Save, compile, and Run again. Same thing. Let's go back to the file, and test stream is there. When you open it, you should see exactly what we output.
Miss,
Yeah?
Miss,
this
Hold on,
program
Mr. Wilby
basically,
first. Uh-huh.
this program, you're right, in Coblox, it basically creates an output document called in a text file. That's what's happening.
All right. What is happening here? Let's go back to the code. What is happening here is that I created a file called test stream and sent an output to it.
Okay.
All right. Now I want to stick to line 11 a little bit and focus on line 11, because I'm sure you understand the out.open and then the file name. But beside the file name, we have an interesting little statement here. iOS scope resolution operator out. All right. What this is just telling it's called a specifier. It is specifying how the output will occur. It's an input-output specifier. This specification, iOS specification, is out. All that means is that it is going to create the file if it doesn't exist and output to the file. If the file exists, it is going to get rid of everything in the file and send your output to it. All right?
Yes, yes.
All right. And I'll prove that to you. Okay. I am going to mess up this file a bit, a whole lot. I'm going to put some strange things in there, and it doesn't matter what I put in there. All right? That's my file called test stream. I am going to save it. Note, this is what is in there. All right? Just junk. Everybody see that?
Yes, yes.
Okay.
Yes, miss.
All right, so let's run the program again. Again, it's the same thing that occurs and comes up on the screen. Let us see what comes back up. Remember my file, which I had messed up? I put in some strange things in there. Look at what is in there now. So, why I did that?
Didn't you see what I put in there, miss?
Yes, I did. And this is part of the issue with using outputs. All right, your specifier here. What this is doing,
does it update it to the latest information?
what iOS out does is to delete whatever was already in the file and start writing from the beginning. So it is an output specifier, which is dangerous. So if you have data there that you don't want to use, you don't want to lose, you do not use iOS out. iOS out will create the file if it does not exist. However, if the file does exist, what it will do is to overwrite, not just overwrite, it will delete everything and write to the file. So it is dangerous. Now, I'm going back to my, I'm going to go back to my folder and again, mess it up. And put in whatever I want to, yeah, that is what I have in there now. Now look at what happens when I change my iOS from out to APP. What APP means is append. And append is find the end of the file and start writing from there. Oh. So look, let's see. Now, whenever you do this, remember, ladies and gentlemen, always compile your program because it is the last compiled program that runs. So now that I've compiled it, I can run it. Again, this is what comes up to the screen, which we're fine with. But let us see what is in my file. Test stream. It found, oops, it deleted it. Why?
Miss,
I
don't think you save it, Miss.
I did
Just write it.
save it.
After you did write it, you never save it, Miss.
All right, let's change this again. But you see, it still works though.
Yeah.
It still works because it found the end of the file and wrote to the end of the file. But I want to do it so that you can see exactly what happens. All right, I don't want it to just be like this. I want you to see exactly what happens. Nobody could remind me that I didn't save it. All right, so let's go and do this again. Close it. Oh. Oh, save it. All right, let's just see what is in there. All right, so that is it. Okay. Okay, so let's save, compile, and run. All right, used to that. Go back here. And there you go. It didn't even jump to a new line. It just went straight to the last thing that was typed and started the output. So that's what append does, APP. All right. Now, APP is safe. And it is safe because it does not delete the information that was already there. Okay. Any questions here?
Yes.
Let me have them.
You can get it to when you append it, you can get it to start in a new line instead of right.
Yeah, you just put an output a new line, just out, and it's instead of doing it like this, I could have just done \n, and it would have started in a new line.
Okay. Where could this be applied?
Anywhere that you need to store data. Now, in your assignment that you're working on, it could be that you need to add some numbers and you need to store it for access or use some other time. Instead of each time having to go to the screen or to type in information, you could have information that's already stored and you access it through a file.
Okay.
All right. Now I want to show you something else. I'm going back to the folder. Now, all my programs are within this particular folder on my computer called, hold on, Mr. Thompson, called P4E. The program is in this folder and the file is in this particular folder. All right. So what that allows me to do is in the program, I just write the name of the file only. I don't have to put a path. All right. However, if I take this folder here and I'm going to cut it and place it on my desktop. Okay. This folder here now is no longer in my file. So if I were to run the program again, it would be a new folder that is created. So if I run that and go back to my file, you'll see a new folder created that is starting from the very beginning. It's not the test stream that was there before. All right. Now, if I want to use the test stream that is found on my desktop, I have to know the path. Now, an easy way to find the path is to open it and, oh dear, where is it? You go to, oh, where is properties? Can I find properties? Not here. You go here and you go to properties. Yeah?
Yes.
And you have here the path. This is my, can you see it? Right here. That's my path. Okay. So I can copy that and put that in, let's go back to code blocks. Put that right here in front of test, sorry, in front of test stream. However, there is a change that you must make. Instead of using backslashes, you must use forward slashes. And I hope this works because it always gives me trouble. But let us see. Yeah. Save and compile and let us run it now. All right, you remember what was in that file? Let's go back to the desktop and make sure that we have a good idea of what is in the test stream on the desktop. We have random information, then the program outputs the squares, and then the squares up to 100. So when we run it again, we should see the same thing below the 100 now. Okay? So let us, did I compile it?
No, miss.
All right, so I compiled and let me run it. Again, we're used to seeing that on the screen. Let me go to the folder first. So this is the one that was in the folder, no change there. All right. Let us go to the one on the desktop now. Hold on. Why isn't it coming up? All right, on the desktop.
Oh.
See what has happened?
Yes.
It
Yes,
is
ma'am.
right there now. And it is able to differentiate from the different folders because in the program itself, I included the path, right? So you can include, you don't have to store in the same folder as the program itself. But if you're doing that, you have to identify the path. And the easiest way to identify the path is to go to the, why is my desktop giving me trouble to find? Go to the folder that you want to store it in. In this case, it was my desktop, and just go to properties, and you are able to identify the location. All right. Only thing you need to do is to change the direction of the slash. You're not using a backslash, you'll use a forward slash. All right. Okay. I need a few minutes, so I need to step out of the classroom for a little bit and come back. But what I'll do, I am leaving other modalities here on the screen for you to look at, and you can try them with your program. iOS in, if you're reading in from your program, you use iOS in. There's nothing else but input. You can't input in any other way but input. There is out, there is truncate. Truncate, it works just like out. It deletes everything in the file and then you can write to it. And iOS append. Now, there are some here that I have in gray. I haven't deleted them, but they don't work in code blocks. All right, they work in other compilers, but not code blocks. So that's why I didn't delete them. Chances are you won't find them necessary. I'm not going to go through them.
Miss, send this before you're done, please, miss.
send this before I go? All right.
Yes.
This is fine.
All right, there it is. All right, so while I am stepping out for a little bit, you can go through the file and you please copy and paste the program and modify it as you choose. All right, I'm going to pause, I'm going to stop the recording and then come back and take whatever questions you have. Okay?
Yes.
Hello? But everybody is gone too?
I don't have any questions.
Okay. Anybody else? This is crystal clear as mud. By the way, this should be stream, not stream. Stream. All right. Okay. Seems simple enough. Anybody trying it? What? You're the only person here. What's the name? Walla? Everybody's gone? Everybody else is gone?
Oh no, miss, I'm here also.
Have you tried it, Miss Robinson?
We are here.
I'm doing it right now, miss.
Okay. All right, so I'll stay on for a little bit longer then, and you can tell me whether or not you are successful with it. All right? So just try it without the without a different path name. Just try it with the same in the same folder, and then you can try it with a different path name. I did change this to TXT. Remember to change the extension on the file to TXT, not doc or docx. Use TXT.
Yes.
Yes.
I just say there's the F-stream file. The error I'm getting is that there's no such file in directory.
Oh, no, change APP to OUT. APP will only, sorry, it will only append a file. So change
No,
it
no,
to,
miss, that's not what I'm talking about. It's a header file.
what do you have, fstream.h or fstream?
Fstream.h.
Okay, take off the .h.
So what's the difference with them? Miss?
In the same way that in other compilers you use iostream.h, in other compilers fstream.h is used, but with code blocks it doesn't use the .h.
Oh,
Yeah, so just take off the .h.
Evening, miss.
Yes.
Yes. If I were to put this as a function, would it still look the same, or it would should I word this? Yeah, how would it look and operate as a function?
What do you mean?
Meaning that because functions are slightly tricky to certain operations. So like, since this is creating a file, but you don't really want to include it in the main file constantly, like this the section of code constantly. If I was to create it as a function, how would that look? Because right now
Exactly as
exactly the
this
same.
looks now. The only difference is instead of calling your function main, you call it something else. It could be void, what no? Whatever you want to call your function. Just give your function a name, but you write it just the same way. You do not need anything in your parameter list unless you must. Can you leave your brackets
So the
empty?
parameter list would just be empty.
It can just be empty if you want it to be.
Okay.
All right.
Yes, miss. Thanks.
Okay then. All right. So I hope this updates it in the folder. Oops. All right. Let's see who is here. Pardon?
Miss.
Yes. Yes, Mr. Thompson.
A question, miss.
Go ahead.
So when you're reading the file, you don't necessarily you can just add text, like text characters to the file.
Pardon? I don't understand. What do you mean?
All right. So could you like read a variable from a .txt file, like
All
like you
right.
can store a
When
float
you
in it and
are,
read that float, or store like just text and read and write.
no, it is numbers. All right. When you are using this particular program, or whenever you're using file streams and you want to do an input, what happens is that if you store the info, you're reading in information, right? You're reading into a variable. So whatever the variable is, that is how it will be represented. For example, if you have numbers there, you read them into a float, then it's a float. Or if you read it into a float array, then it is an array, is a float array. They're all floats. However, if you read them into a char, if you read the value into a char, then it is a character and not a number. All right? So it depends on what you store the information in. All right, let me see. I don't want to create one from scratch right now. Let me see if I can find an example of one that I have before.
So, Miss, you
I'll upload
would be
one with
able to read the
all right, tell you what.
variables, like you would be able.
All right, hold on. Tell you what, I will upload a program that does both input and output. Here is one that I have here on screen. This is reading information in from a text from a program called Sample. It's not gonna work right now because I don't have a folder called Sample. I'll have to go and create it because if you're reading in from a folder, from a file, the file must already exist. So if I run this, what do you think will happen? Let me save it in my folder.
It's gonna retrieve the file.
It's gonna retrieve it?
Yes, and output it.
Okay, let us see. So remember that this one is just reading in information that is in a file called sample.txt. I have iOS in, and if in is open, then what it will do is read in the information into array X, and then it will square the information and store it in array Y, and then it will output the information of array Y to the screen. However, if it didn't read the information in, it will output file does not exist. All right. So what do you think it will do? It will read in the information, square it, and then output it, or will it say file does not exist?
Still read it, Miss.
File does not exist.
I don't have anything in here called sampling. Got my
Or read them.
it can't read. It should output file does not exist.
Can you read it from the one that just created this? The text file.
Okay. Yes, it can. Now, the problem with my text file, and I don't want to because I have some writing, it's not just numbers only, but I have some writing at the top. So what I will do is find Notepad. Where is Notepad? All right. Let's find Notepad. So where is Notepad? Accessories.
Type it in search.
It should be just here. I just use that. And new. All right, let's put 4, 5, 8, 9. And what was the name of it? Well, what was the name of the sample?
Yes, miss.
Save as, and let us call it P for E. Let's call it sample. Okay, so that is what is in my sample. All right, so let us try it now. Save, compile, and run. All right. Ooh. Sorry, my computer is gonna block it. Let's see if it did do anything. It's not gonna do anything. My computer is blocking it. It sees my program as dangerous. Let's try it again.
Yeah, what happened?
Yeah. Did it allow it this time? It seemed as if it allowed it. No, it's not allowing it at all. Huh, I can't. Oh, where is it? Where is it? Where is it? Where is it? It's not gonna change it right now. What I suggest you do, try it on your computer, all right? I'm going to have to change my settings, my security settings to get it to work. But try this one. I'm gonna upload, let me save it as something else. The names are too close. Stream sample. And I'll upload that as well. All right, so you can try that one as well. So this one does both input and output. But in order for this one to run, you must already create this text file and you must have some numbers in it. Okay, and then what it will do is calculate the squares and then append the file and close. All right, ladies and gentlemen.
And one final question, Miss.
Yes, Mr. Thompson.
Yeah, about space. So if you would take out a space, you would read it as one number or character.
That's right. If it doesn't have spaces, it's going to read it as one piece of data. Unless you are storing in a character or character array, then each individual character is taken separately. If you're storing it in a a float or an int or a double, then you need the space. Does that answer your question, Mr. Thompson?
Yes, Miss.
Okay, very good. All right, so I'm going to leave it here. If you have any questions on this, can you send me an email and post it in the group so that everybody else can see it? Although if you prefer to send it only to me, that's fine. You can send it only to me. All right?
You upload this new file?
Yes, I have. All right, and that ends our lectures.
Now to the meat of the matter.